In this video, we're going to get a handle on linear equations in two variables. We'll look at the solutions of them and the graphs of them. First, let's talk about what linear means. A linear, and this is a very fundamental, important definition. A linear equation is an equation. Of course, an equation has an equal sign, it has a left side and a right side. So a linear equation is an equation where each variable is only raised to the first power. They are not raised to higher powers like second, third, etc. Okay? So a linear equation is one where the variables are raised to the first power. You can have as many variables as you want, but only to the first power. And when you raise a variable to the first power, you don't really see the exponent. So let's see some examples here. 2x plus 3 equals 4z minus 9. This is linear because x is to the first power and z is to the first power. You don't write the ones because you don't need to, but they are to the first power. If I have 2 minus 3x squared equals 12 plus y, y is to the first power, but x to the second power is not to the first power, so this is not linear. If I have 2x times x minus 3 plus 4y equals 7, well, this is not linear either, because if I distribute my 2x, I get a 2x squared minus 6x plus 4y equals 7. And now, because x is squared again, this is not linear. So linear, the variable has to be raised to the first power. Okay? So this is a linear equation here. We're going to look at linear equations in two variables and their solutions. Okay, so let's look at a linear equation in two variables. Since we typically use x and y axes when graphing in two dimensions, we will also typically use x and y as our variables when we work with linear equations in two variables. Okay? So typically x and y, it doesn't have to be, but typically x and y because our graph is usually an x and a y axis, which we also know you don't have to use x and y. So here is a linear equation in two variables. 2x minus y equals 8. X and y are both to the first power, and we have two variables. So this is a linear equation in two variables. Now, if we have an equation in one variable, so let's organize here. So this is linear in two variables. And over here, let's look at linear in one variable. Let's make that bigger so it all fits. So let's just say maybe negative 2y equals 8. Okay. These are similar and different. If I want to look at a solution to this, a solution in one dimension, that would simply be y equals negative 4. Because if you plug negative 4 in for y, negative 2 times negative 4 is 8, so the equation is true. A solution to an equation is a value for the variable that makes the equation true. Let's write that here. makes the equation a true statement. Okay? So, over here, y equals -4, and that is the only solution. That's the only y value that makes this true. Over here, a solution needs to make this true, but I have two variables. So a solution over here has to be two numbers. So a solution here has to be two numbers, so in two dimensions. Here I had one variable, so I only needed one dimension. Over here I need two dimensions. So let's say x is 0, for example. So if x is 0, what would y have to be? Well, 2 times 0 is 0. So let's write this out. 2 times 0 minus y equals 8. So 2 times 0 is 0. So on the left side I've got -y equals 8. And then divide both sides by -1, and we can see that y is -8. So if x is 0, then y has to be -8. I need an x value and a y value for that solution. Well, that can be written as an ordered pair, 0, -8. So this is a solution to this equation, whereas over here this is a solution. So in two dimensions, you get an ordered pair solution. In one dimension, you get a single number solution. Okay? Now, there are many other solutions to this equation. In fact, there are an infinite number of solutions, and they are ordered pairs, so infinite number of ordered pair solutions. Over here we had one solution in one dimension. But what's cool is when you have one variable, you can also look at solutions in higher dimensions. But when you have two variables, you can't look at solutions in fewer dimensions. You can't have a solution to this that just has one number. You have to have at least two dimensions when you've got two variables. So over here, if you want to look at a solution in two dimensions for this guy, which we can do because it's only one variable, so I can go to higher dimensions. All that matters is that, so a two-dimensional solution would be an ordered pair, two numbers. Y has to be -4. And x can be any number. So you can see there's an infinite number of solutions to this equation in two dimensions. All right? Okay, so now let's play around with both of these equations a little more. Linear equations in two variables have infinite solutions, and they're ordered pairs. If we could graph all of these ordered pairs, they would form a straight line. So that's where the word linear comes from. So we will use that now to help us graph both of these equations. So let's look at 2x minus y equals 8, and let's look at -2y. Oops, let's do this. -2y equals 8. And I want to graph these, and I know they're both going to be lines because they're both linear. Now, if I want to graph a line, you have to have at least two ordered pairs. We need at least 2 points to graph a straight line. Right? If you have 2 points, then you can graph a line. So what I'm going to do is I'm going to graph these, and I'll do that by I'll do 3 points, 3 ordered pairs. So we could do that with a table. So I'll set up an XY table here. And I'll do the same thing over here. So I'm going to use 3 ordered pairs. What I can do now is I can plug in anything I want to this equation for x or y and then solve for the other. So let's say x is 0, which means that if I were to solve for y, I'd have 0, because 2 times 0 is 0, minus y equals 8. So negative y equals 8, which means that y equals negative 8. So we get the ordered pair 0, negative 8. Then let's use another one. Let's say x is negative 2. Then I'd have 2 times negative 2 is negative 4, minus y equals 8. Add 4, so negative y equals 12. Divide by negative 1, and y equals negative 12. So I get another ordered pair. And let's say I plug in 4 for x. Remember, there's an infinite number of these, so I can pick whatever I want. So if I plug in 4 for x, 2 times 4 is 8. So I get 8 minus y equals 8. Subtract 8 from both sides, and divide by negative 1, and I get y equals 0. So I've got 3 points now on this graph. I've solved for my y values by plugging in x values. I could also plug in y values and solve for x. It doesn't matter. So if I were to graph this now, 0, negative 8 is down here approximately. Start at 0 on the x, go down 8 on the y. The negative 2, negative 12 means go left 2 and down 12. So maybe like here. And then finally 4, 0 is maybe over here. And then I know that this forms a line, and my points that I've gotten confirm that. So I draw the line, make sure to indicate that it goes forever in both directions. What this line represents is every point on this line, every ordered pair, makes this equation true. So every point is a solution. So you can tell that there's no ordered pair in quadrant 2 that will make this equation true because of the line. All right. Okay, let's look at the next one. In the next equation, I already know that my y values all have to be negative 4. So for my 3 ordered pairs, I know my y values have to be negative 4. And my x value, because there is no x can be anything. So maybe x is negative 2, maybe x is 0, maybe x is 5. Now if I plot those, let's see what it looks like. Negative 2, negative 4 is down here, let's say. 0, negative 4 is right there. And 5, negative 4 is down here. And I know it makes a line because it's a linear equation. And what we get is a horizontal line. Again, every point on this graph is a solution to that equation. So if we look at equations with one variable in 2 dimensions, we get a horizontal line, as we see here, or a vertical line. So a vertical line would happen if you have x as your variable with no y. But you can see by plotting the points that it's horizontal, no problem. Over here, if our equation has 2 variables, we get a slanted line, not horizontal or vertical. All right, hopefully that helps you with linear equations in 2 variables.